Going throttle up.
Discovery, roger. Go for deploy.
Stich 2, and everybody in the shuttle program, the crew is go for launch.
Roger. Nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Good afternoon, everyone, and thank you for joining us here at NASA's Johnson Space Center as we discuss the arrival of the NASA's Boeing crew flight test mission to the International Space Station. Boeing's Starliner spacecraft arrived at the orbiting laboratory today at 12:34 p.m. Central Time, delivering NASA astronauts Butch Wilmore and Suni Williams on what is the first crewed flight test for the spacecraft. Joining me to talk about today and the accomplishments that we've seen are NASA's Associate Administrator Jim Free, Steve Stich, Manager of the Commercial Crew Program, Emily Nelson, Chief Flight Director, Jeff Arend, Manager for Systems Engineering and Integration for the International Space Station, and Mark Nappi, Vice President and Program Manager for the Commercial Crew Program at Boeing. We have several media already in the queue today, so just a reminder before our participants begin their opening remarks, you can press *1 to raise your hand and let us know you have a question. And if you hear your question answered, you can press *2 to lower it. We'll get to those shortly, but to start us off today, I'm going to turn it over for some opening remarks. We'll start with you, Jim.
Thanks, Leah. Well, good afternoon, and what an exciting couple of days we've had. On behalf of the NASA Administrator, the Deputy Administrator, and the entire agency, thank you and congratulations to the NASA team, the Boeing team, on the successful docking of the Boeing Starliner with Butch and Suni on board. I am so proud to watch this team in action. They really make it look easy. For all the issues that came up today, that's come up on this flight, they make it look easy. I hope you all appreciate that. Advancing human spaceflight is not an easy task, but achieving our goals returns value to our nation. I think Butch highlighted that in his speech before launch yesterday. Value to our space program and to the science it enables to improve life of every person. We had a vision to increase the reliability and safety of sending NASA astronauts on their missions to the ISS while returning the capability to do so from the United States through a partnership with American private industry. We are continuing to make that vision a reality. The launch yesterday and docking today puts the Starliner on a path to certification, to enabling continued exploration and science that benefits humanity. Butch and Suni have already performed some of the manual flying tests of Starliner that will provide valuable data about the spacecraft's navigation and steering. And it's great to see them both aboard the space station again since their last expeditions there in 2014 and 15 for Butch and 2012 for Suni. I want to specifically acknowledge them and thank them for the years they have spent to getting us to this point. The expertise they bring to their roles and their dedication to the task of advancing human spaceflight by proving the end-to-end capabilities of the Starliner system in space. We look forward to their feedback. I know we've already received some, their insights as we all continue to learn throughout the remainder of this test flight. Starliner is an important part of maximizing the benefits of the ISS, and it's so great to see it docked and connected to the station for the rest of the mission as they become part of that station ecosystem. This flight and future Starliner missions are also informing our deep space exploration plans for Artemis. Starliner's docking system and a number of other elements also will be used by our deep space exploration crews. An experienced NASA mission operations team embedded with Boeing is fulfilling the flight operations role directly. This team will also apply its lessons learned to the Artemis missions. And when Starliner is certified, the United States will have 2 unique human transportation systems for ISS, and no other country in the world has that. Again, I extend my congratulations first to the ULA team for the launch, to Boeing, Mark and his team, and Steve and their team, Emily's team in Mission Ops, to get Butch and Suni to ISS. And I look forward to continuing to follow the test flight, its conclusions in its operations on ISS, and its safe return to Earth. With that, let me turn it over to Steve.
Yeah, thank you, Jim. Thank you for those kind words, and thanks to all you for continuing to follow the Commercial Crew Program and our Starliner crewed flight test. I would like to congratulate the entire team on a wonderful docking this morning, just a little after 1:34 Eastern. It was about an hour and 15 minutes delayed, and we'll talk a little bit more about what the delays were caused by. But again, the team did a great job. The flight operations director that Emily will talk more about, working hand in hand between the Starliner flight control team, the ISS flight control team, and then the Starliner and NASA engineering teams, all working together to solve problems. It was just incredible to watch that. The past 24 hours have been a testament to what it's about in human spaceflight, and really all the hard work that they poured into this spacecraft over many years to get us to this point. You know, Tori yesterday talked about it's not easy. The rocket gave us a few challenges, and today I would say, you know, Starliner made us work a little harder to get docked, but it was great to watch the team in action. And, you know, a really great day for me to watch Suni and Butch come across the hatch and be part of the station crew. It's something that the commercial crew program has been working toward for so many years, to have the two vehicles, Starliner and Dragon, docked at the International Space Station with two different crews now. And watching them go to work, it was just incredible to watch that happen. You know, Butch and Suni are kind of the face of the mission. It was great to see them. You know, Suni was so excited to come through the hatch. He was bouncing around, and great to be back on the space station. Today's docking, I think, was challenging. We had a few things that we had to work through as a team, and I'll talk a little bit more about those, but the ops team did a great job working through those. So I'll try to recap what it's been like over the last 24 hours. You know, yesterday on flight day 1, the crew got on orbit. They spent some time checking out the spacecraft. We mentioned yesterday that the sublimator, this is a device that's used for cooling during the launch phase and then also during the entry phase, used a little bit more water than predicted. We think maybe there's an ice block that forms, and maybe that didn't form quite like it needs to form. The crew spent some time. We have a refill kit, so they filled the tank back up just in case we would need it. We have enough water to use that for entry coming up at the end of the flight. So we'll have plenty of capability there, and we'll learn a little bit more about the sublimator. If we look forward to Starliner 1, we have already, Mark and his team have worked on a design upgrade and have a little bit bigger tank already sized for that mission for 4 crew. So we already have that in place for Starliner 1. It was kind of nice to watch the crew do that work. We had a number of manual piloting demos yesterday that we did through, where we worked with Starliner to manually point the spacecraft to get communications with the tracking data relay satellite. Those went well. To maneuver to charge the solar arrays. You could just tell by Butch's voice that he really, being a test pilot, Butch and Suni loved doing those, and that all went well. Toward the end of the day yesterday, I would say it was around 4:30 local time here in Houston, after they had performed some of the demos. We noticed a little bit of an increase in the helium leak rate that we talked about pre-launch. We could see at the tank level, when the system is opened, essentially you're bleeding helium from the tank all through the flight. And we could see that that leak rate was a little higher than we had thought pre-flight. So we took an action that already exists in the procedures. The flight ops team, working with the crew, isolated all the manifolds, and we concluded that the P2D2 flange leak, that was the port doghouse manifold 2 leak, was essentially about exactly what we had seen pre-launch. It was about 20.4 psi per minute. That was very consistent with what we saw at the pad when we checked the system out, and also when we got back out to the pad. So that was left open overnight. What we found also was 2 other leaks in port manifold 1, and that leak was a little larger than the ones we had seen before, 395 psi per minute, so it was a new leak. As a precaution, because we didn't need the capability to have all the thrusters, we're just maintaining attitude, pointing the tail toward the sun. We closed that manifold overnight and slept in that configuration. And also in the top manifold 1, we saw a new leak. It was about twice what we had seen in the port manifold, 42 psi per minute. We also closed that one overnight. And so we put the crew to bed. We were in that good config. We knew we were going to set up for a rendezvous the next day. So the ground teams, the engineering team went off, worked with the ops team to talk about how to manage that. Essentially what we did was we followed the flight rules and looked at the margins for the mission. So going into the mission, obviously, we needed about 108 hours of total mission time to execute the first rendezvous. And then we protect for contingencies, a 1 rev delay on the rendezvous, and also 1 day delay in the rendezvous, and then the deorbit and entry, undock, deorbit, and entry, plus delay time past that. So when we looked at all those amount of hours required for the mission, we knew we needed, at that point, about 90 hours of the mission was left, and we had about 140 to 170 hours of total helium capability. So we had way more margin than we needed, so we pressed on into the rendezvous. And to do the rendezvous, we actually opened the manifolds up and had all the thrusters available. So that was the safest course of action, and we made the system back to nominal. We had a Starliner MMT and an ISS mission management team overnight, and everybody pulled go to proceed into the rendezvous this morning. Crew got up early, about 4 a.m. Eastern this morning. We did a handful of phasing burns with Starliner today. Those all went well. Those early burns were with the orbital maneuvering and control thrusters. Those went well. Then we did the final, what we call the TPI burn. That's a burn that puts us on intercept with the space station. And at that point, we started to see some loss of some of the reaction control system thrusters in various doghouses. These were all aft-facing jets that we lost. We don't necessarily understand exactly why we lost these aft jets. We do know we point, Starliner, the solar arrays are on the aft part of the service module, so we point that part of the Starliner at the sun. And then several of them were exactly the same thrusters we went back and lost on OFT2. So we ended up losing a total of 5 thrusters, starboard 2A2, the bottom doghouse 1A3, bottom 2A3, starboard 1A1, and the top 2A2 thruster. Now, we recovered 4 of these 5 thrusters, so what we did is once the thruster fails, when I say thruster fails, what I mean is the software sees something that it doesn't like about that thruster. So the thruster is maybe a little less thrust, or the thrust rise rate doesn't come up exactly the way that the software is looking for. And so what the software does is it says, I won't use that thruster anymore. And so when we say failed thruster, we're talking it's not available for the GNC flight software to use. So those happened on those 5 thrusters. We actually put the vehicle into what we call free drift. And so, in other words, there's no thruster firings on the vehicle. And then we fire only 1 thruster, and we know what the rate should be for that thruster. So we did that with 4 of the 5 thrusters, and we recovered 4 of those 5. 1 thruster, the signature looks very strange and a little different from the other ones, and that was the B1, the bottom one, A3 thruster, and we left that thruster inhibited for the rest of the flight. So again, these thrusters are similar to what we saw in OFT2. We don't quite understand why they're happening. We took a couple of actions in the software to mitigate potential fail-offs by the GNC part of the software. Again, we recovered the thrusters, and they were working just fine during the rendezvous, except for 1 that we left inhibited. These are not at all related to the helium leak. The helium leak is separate. It's in different doghouses. It's different thrusters, so the helium leak and the thrusters are not at all related. We have plenty of redundancy today. We took a little time as we worked through the rendezvous sequence to recover the thrusters. We had the crew at various points do manual flying, worked hand in hand with the Starliner flight ops team to do that manual flying. We did all this work outside of what we call the sphere, which the keep out sphere of ISS. We want to really be outside about 200 meters, and we did a lot of this work there. Once we got the redundancy we needed, we pressed on in. Both flight control teams were go. And a real positive was that the crew did the manual flying in a different way, but working hand in hand with the ground, and so got a lot of good data on the manual flying of the vehicle. This whole timeline took a little longer than we thought, so we missed that first docking window. We set up for the backup docking window and proceeded in and rendezvous just on time. I think we'll have to take a little bit more time to figure out what's going on with the thrusters. Again, the rest of the rendezvous went really well. The Vesta system, which is the navigation system, worked great the whole time. All those sensors performed well. The NDS system, the NASA docking system, which Jim talked about is going to be used for Orion, worked extremely well. That system performed nominally. And so most of the vehicle did awesome going into the rendezvous. Butch and Suni did report a little bit of residue on the forward-facing window. That's a window that's in the hatch on the forward part of Starliner. We weren't sure what it was. We wanted to make sure it wasn't related to some thruster firing or some residue. We examined that, and it was no concern. We just took a little extra time opening the hatch to make sure that there wasn't a concern from that. And then finally, toward the end of the day, once we got docked to the ISS, we closed the manifolds in the helium system as planned. That was always part of our operation, and we did find one extra leak in a helium leak in starboard manifold 2. It's about 7.5 psi per minute. It's a relatively tiny leak compared to the others. So, helium's a small molecule. It's easy to escape seals. So we've got to go, what we need to do over the next few days is take a look at the leak right there and figure out what we go do relative to the rest of the mission. In looking at the numbers, just at the top level, we should have absolutely plenty of margin. We didn't need an extra rendezvous day, and we'll go look at the numbers and figure out how to manage the helium manifolds. So overall, we're really enjoyed to have Butch and Suni on station. We've got a lot of work for them. We're not yet ready to talk about landing opportunities. The earliest one would be on June 14th. We want to work with Jeff and the station team a little bit to talk about what Butch and Suni will do while they're at station, and then we'll set up for landing when we're ready. So with that, I'll turn it over to Emily.
Thanks, Steve. Thanks for joining us today and for your interest. I could not be more proud of our Starliner flight control team, our ISS flight control team. They, together with Butch and Suni, have been working incredibly hard to train for this mission. And spaceflight is never easy, but today they had the real opportunity to demonstrate what that preparation really means and how that pays off when you end up with surprises and you get to navigate all of those and succeed at the end of the day. It's a real testament to the amount of work that all of these teams have put into making today successful and getting us to this momentous point in the commercial crew program. We are so excited to see Suni and Butch on ISS again, and we are really looking forward to a really busy mission with those guys as we get through a couple of heavily dynamic phases of this mission and then move into the next phase, really putting Starliner through her paces and preparing for future missions. With that, I'll hand over to Jeff.
All right. Thanks, Emily. And again, thanks for joining us today. And I just want to echo the congrats that everybody else did, the Boeing team, CCP, ULA, FOD, obviously, since they're the whole upside of this whole group achievement, and all the other NASA teams that came together. It was really awesome to see. It's good to see Butch and Suni back on station, as everybody else said. I certainly don't have the dance moves that Suni has. If anybody watched her float onto station, that was absolutely awesome. So they'll work to continue to acclimate to space station once again. We're also hoping, and it was alluded to by Steve and Emily, that we can also get them to do some science and maintenance activities for us. Obviously, one of the big things that the Boeing CCP team really worked hard for us was to change the load of the hardware that was being brought up. They had to rearrange a few things because we have a processor that we really need to get on space station. It's the one that actually allows us to process urine, and between storing urine and needing a lot of water when 9 people are on board, it's a really big deal to us. So, in fact, the plan is to actually try and put that item in place tomorrow, do the R&R, get the UP up and running, and that will probably factor into our decision on when we all come to an undocked decision together as a team. So looking ahead, you've probably heard in the past we have a series of spacewalks over the next month. TC and Matt are going to go out. We're targeting, believe it or not, it's the 13th, so it would be the day before the 14th. So we probably need to decouple those. So we need to talk more about that. The first EVA is to remove an electronics box on something called our RF frequency groups. You probably heard the acronym RFG. So, but that, yeah, we definitely need to restore that to health. And then we are targeting a couple other EVAs about a week apart after the 13th, so we'll see how that goes. We have an antenna group that we need to move that we're finding doesn't necessarily always have great line of sight and great comm, so that's what we're going to do on the second EVA. And then there's another IROSA mod kit that shows up that we're planning to do on the third EVA. So, yeah, we're super excited. Really glad they delivered that one ORU for us. And yeah, in summary, it's just great to see Butch and Suni back on space station. So with that, I will hand off to Mark.
All right. Thanks, Jeff, and thanks, everybody, for joining us. Wow. Yesterday was exciting. I didn't think we could make it more exciting, and we did that today. It was amazing. We accomplished a lot, and really more than expected. You know, we exercised the team, we exercised the crew, and just had an outstanding day. We had two phases of work. We had a bunch of planned work we had to go do, and then we had some unplanned work that happened that Steve talked about, but we learned from both of those, and we got a lot accomplished. On the plan side, Steve talked about using the hand controllers and the manual piloting. We did a breakout maneuver as we were approaching the station to make sure we could do that. The crew talked a lot about the displays and the suits and the seats, and they performed the hatch operations to get us into the station. And all those were part of the planned flight test objectives and operational checkouts that we wanted to go do. So check, all that stuff was completed. On the unplanned side, we had some helium problems. So the team did some incredible troubleshooting, exercised the teams back at Mission Ops and back in Florida, and they were very well prepared for this and really just instituted the flight rules or the techniques that we've talked about for the last 3 weeks, because we suspected that maybe something like this would come up, and we were ready for it. So by 3 o'clock this morning, when we had an MMT, it was smooth as butter. We just went right through it and made the decision to recommend going towards docking. Of course, the jet failures that Steve talked about, we ended up doing two jet firings to bring those back online, successful, and we've learned something from that. We filled the sublimator with water. That wasn't planned to do when we did it, and we got that done. And then there were a bunch of team dynamics that took place with the mission operations team, the ISS team, their backup rooms, our backup room back in Florida. All those teams were really working well together to solve these things that came up. So we went through some changes. All this is beneficial to the team, and it's all beneficial to us learning what we need to learn so that we can make this vehicle better. We went around after the docking, lots of smiles on people's faces, and we talked to folks, and I can't tell you how excited everybody was and how proud we are of them and how proud of they are of this vehicle and what we accomplished today. There was a lot of, I'll call it chatter on the air to ground with Suni and Butch, and it was just crazy to listen to. They were just so complimentary of things. They talked about the vehicle handling and how precise it was, how it was even better than working with the simulator. They had suggestions, they had improvements. They talked about things, don't change this because this works really good, and they had some just techniques, this works a little bit better if you do it this way than if you do it this way. All stuff that you are not going to learn unless you go through a test flight. That's how you learn these things, and that's how you pass them on to the next crew. So it was a test flight. It is a test flight. We said we were going to learn from it, and you can see that we've learned some things, and we're going to apply those to what we do next. As the day went on, we talked to Scott Tingle and Mike Fink and Josh Kutrick, and they were excited about this, and they talked about all the learning and what they were going to do when it's their turn. And so it was just a great day all around. Yeah, we had some things that we ran into, but that's exactly what we wanted to get out of this mission, and really can't say enough to thank the mission operations team, the International Space Station team, that all worked together with our team to make today happen. The goal was to get to ISS. The goal was to dock. The goal was to get Suni and Butch safely on the International Space Station. Mission accomplished.
Don't forget the pump package.
And and deliver the pump package. Bonus.
Right?
Mission accomplished there, too. Thank you all so much for your opening remarks. We're now going to move into the question and answer portion of our session today. And as you know, we have quite a bit of interest in this mission, so please limit yourselves to one question to start off with. If you have a question, press *1 to raise your hand, and if you hear your question answered before you have a chance to ask it, please press *2 to remove yourself from the queue. We will start out with Gina Sinceri from the ABC News.
I think this is for Steve Stich. I know this is a test mission, but did you guys decide to throw in a pop quiz this morning?
It felt a little bit like that. I think it's a test flight, and we expected to learn things. And I think the thing that was great to watch is just how well the team handled each and everything that came their way. So, I'm excited as a commercial crew to get this vehicle docked safely, to see all the systems perform well. We've got quite a bit of work to do when we're now at station. We want to do some of the test of habitability with the crew and talk about how we extend the 2-crew mission to 4, do the demonstration of the safe haven, and then we'll figure out when to undock and land a little later. But the thing is that the team handled the pop quiz really well, and they got all the answers right.
Thanks, Steve. Our next question is from Marcia Dunn with the Associated Press.
Yes, hi, thank you. Probably for you, Steve, as well. More helium leaks, thruster problems. How worrisome is all this, and where does that leave Starliner when it comes time to come back? Is this going to ratchet up the risk?
Yeah, I think, if I take it one system at a time, we talked about the sublimator using a little bit more water, so we've refilled that sublimator. We know that we have enough water for entry, and with 2 crew on board, we know the heat load is low enough to where we have plenty of cooling capability on the vehicle, so that problem is not a concern for entry. In terms of the thrusters, we recovered all the thrusters. We only have one aft thruster down. Shouldn't be an issue for entry, for the deorbit burn, or any other phase of the flight. And then the helium system, we just got to take a little time to see what the budget is and what that means for the rest of the flight. So I think if you watch what we did today with the team and how we performed, we'll do the same thing over the next day or so. We'll take a look at the helium leaks and the manifolds and figure out what the plan is to manage. The good thing about the rest of the flight, the most demanding phase from all the thrusters that are needed on the service module really is the rendezvous and docking phase. The rest of the flight, the undocking doesn't require quite as much redundancy and quite as much helium, and then we can actually close manifolds for the rest of the flight phases. So I think we have some tools in our toolkit to manage this. We'll take a little time to go assess it, and we'll undock and land when we're ready.
Our next question is from Jeff Faust with Space News.
Hi, question for Steve or Mark. With, I think, now 4 helium leaks, is there any reason to believe that there's a common root cause for some or all of them, or are they all leaking for different reasons, do you think? Thanks.
So we've talked about that quite a bit today. They are very similar in the way that they're behaving. So there's a good reason to believe that they may be similar, but we certainly can't rule out that there could be it's and this or it's or that. So we're going to look at everything real closely. Those manifolds are locked up now. That gives us time to kind of think about this a little bit more and troubleshoot. The goal today was to get docked to the International Space Station, and that's what the team focused on. So we're there, and now we can sit back and think a little bit more about what kind of signature did these leaks have, what could be common to each one of them, and what might be different, and then we'll go from there. But I think we probably all lean a little bit more towards there is some commonality here, and we're going to take that very seriously.
Thank you. We'll now move on to David Bonneau with About Space Today.
America and the world has been amazed at the journey of Starliner getting into space. But today, I want to talk about a side story, if we could, and I would appreciate some embellishment on this. I noticed in the mission control today It was a gentleman, and I, please don't hesitate to explain who that was, had a nice orange tie on and orange socks. This kind of enthusiasm has not been seen in a long time. Who was this man? And tell me the backside of the story, please.
Go ahead, Emily.
Okay. I'm assuming you're talking about Mike Fink. At least that was the brightest tie I saw in the room. The tie was actually presented to him by Butch. He is the backup crew member for Butch and Suni. There's a tradition, as I understand it, in the flight test community where you wear bright orange. Yep, there he is. You wear bright orange associated with flight test. That particular tie, if you were able to zoom in, there you go. It's signed by Butch and Suni, and so that was. There were actually a number of orange ties in the room today in honor of the fact that this is a test flight. And so Mike's, I think, were probably the brightest and maybe the most prominent. But yeah, he's on our Starliner 1 crew and proud of the work that's been done on this flight so far.
Thanks, Emily. Our next question comes from Tim Fernholz with Payload Space.
Hi there. Thank you for taking my question. I was curious, when you were assessing the helium leak on the ground, you thought that was either an installation or a material defect. Is there any reason to reassess that now after the issues on this flight? And then just logistically, when the spacecraft is going to deorbit, how much time lapses between its departure from station and a deorbit burn? Thank you.
I can take the first part of that. Yes, it certainly is something that we're going to reevaluate. On the ground, we had one flange that was leaking helium, and we suspected that maybe that seal could have been damaged or whether there's some foreign object debris in that cavity. And the rest of the flanges were all tight. There was no leakage whatsoever. So now that we're in flight and we've seen a couple more leaks, if it is a common cause across those flanges, then there might be something more to the flange itself, maybe a bad lot of seals or some other variable. So we're going to have to take that a little bit more seriously and take a look at it. And again, now that we're on station and those manifolds are locked up, it's going to give us some time to think about it and possibly do some more troubleshooting.
Yeah, I think Mark said it very well on the seal. We'll have to go back and do some troubleshooting on the ground. I think, we'll take a look at Starliner 1 flight, go look at all those seals and be able to leak check them maybe more thoroughly and see if there's anything else that we got to go look at. In terms of the time from undock to landing, it's roughly about 4.5 hours or so from the undock time to the time that we execute what's called the deorbit burn, which that is the burn that takes the energy out of the orbit that puts us on an intercept with the atmosphere. And then from the deorbit burn to landing is roughly on the order of about 40 minutes or so. So a total of, a little over 5 hours and 15 minutes or so from undock to landing.
Thank you both. Our next question is from Joey Roulette with Reuters.
Hey, thanks. Question for Steve and maybe Mark. How much helium is left on the capsule and how much do you absolutely need to return? And then on the thruster issues, how many thrusters can you lose and still safely return to Earth? Or I guess, in other words, what's the minimum number of thrusters that are absolutely required to make deorbit and return possible? Thanks.
I'll take the second part. I don't know exactly how many we could lose. We're only down one thruster right now, so I can go get that number. The redundancy really is there for a couple things, mainly for the approach and docking to station. We need redundancy as we approach station, and then, after we execute the deorbit burn with the service module actually does its own disposal. So this service module will end up in the ocean, so we need a number of thrusters to actually back away from the crew module, and then it spins up, and then it executes a little bit of a burn there, so we can go get that for you. I think we're not necessarily worried about all the thrusters for the rest of the flight. If we go back and look at what we did for OFT2, as a matter of fact, when we recovered the thrusters on OFT2 2 years ago, a little more than 2 years ago, Those thrusters did well after we brought them back in and used them for the undock to deorbit phase. In fact, I was looking today, I can't remember which thruster it was, but one of those thrusters fired another 500 pulses as it held the orientation of the spacecraft during the deorbit burn. So we think right now there's something that causes the thrusters to fail, and we don't know exactly why. In between the phase where we're pointing at the sun for a long period of time, get into the rendezvous where we're pulsing these thrusters quite frequently, and we don't do any of that, that rapid pulsing for the remainder of the flight. And then I'll be honest, I've been up so long I forgot the first question, so maybe
I can
Mark.
So I'll give you some old numbers, but then we'll explain what it means for the future. Last night when we took a look at this and decided whether or not we had a good situation to go dock, Steve said it earlier, we needed 90 hours of helium to conduct the mission, but that included all the things Steve talked about with multiple rendezvous. That's already behind us, so we don't need that anymore. So that goes in the bank and reduces that 90 hours to something less than that. When we went through the meeting this morning, we had calculated that we had anywhere from 135 to 175 hours on hand. And the reason there's such a big range there is because we were doing those calculations with respect to the whole ullage system and not isolating the manifolds like we can do now once we're on the International Space Station. And the temperatures were also affecting that. So now the teams are going back and recalculating those numbers. The 135 to 175 will likely go up, and the 90 will likely go down, which gives us a lot more margin than we thought we had last night.
Thank you. And our next question is from Eric Berger with Ars Technica.
Thanks very much for doing this. Just wanted to clarify something Steve said earlier about.
We're not hearing Eric in the room.
You mentioned that there was some commonality in the thruster failures observed today and during OFT2, and then you said you didn't quite understand what was happening. Are you saying that the RCS thruster issue from OFT2 is still not understood, or do you think it's a different problem with these thrusters that's not understood now? I'm just trying to clarify whether you had sort of closed out that issue on OFT2 before this mission. Thanks.
Yeah, but when we had the failures on OFT2, of course we recovered them and used those thrusters during that flight. We went back and made a couple of changes. One, we found that the software needed a little more time. When the thruster gets commanded, it takes a little bit of time for the thruster to go from, it measures the pressure in the chamber, and there's a rise rate on that, and it's looking for a certain time to get up to a certain level to declare the thruster healthy. And so we made a change there, and we thought we had fixed that problem. We made another software change to look at the number of persistence. It has to pass a number of checks to declare a thruster healthy. So we increased the number of times required to fail a thruster. It needs to be 5 consecutive times now. We made those 2 changes, but I think we're missing something fundamental that's going on inside the thruster. Maybe how the heat is soaking back into the thruster and the various components. There's this pressure chamber measurement that I talked about that is a piece of electrical instrumentation that's maybe a bit fragile, so maybe that's part of the problem. And then we got to go look at how the combustion is occurring. So again, the thrusters work fine most of the time. They worked fine yesterday when we had Butch and Suni doing some manual flying. They work fine to hold attitude control. It seems when we get in this rendezvous sequence where we have to point in a very precise manner, and then we have to fly in a very precise manner, where we're pulsing the thrusters rapidly, that we're building up something in the thruster that's causing the software to declare them failed. When we hot fire them, we were able to recover them. So we've got to do a little bit more research to figure out what's going on.
I think I'd add to that, this is part of where the learning really helps, and having 2 data points rather than 1 data point. We don't get the service module back, so we have to use the data that we get from the flight and then build a fault tree and determine based on that data what's the most likely causes. And then we try to address those. And that's just 1 data point because it's just 1 flight. When you now have this flight with the same types of failures with a bunch more conditions and a bunch more data that's going to help us narrow in on that fault tree and determine what's going on here. So this is how human spaceflight works. This is how engineering works. We do these tests, we gather more data, and we learn more, and we fix it.
Thank you both. The next question is from Michael Sheets with CNBC.
Hi, everybody. It's Michael. Appreciate any clarity from Steve or Mark here on this question, but with the 5 thrusters that you saw have failures, was there a commonality between those failures that you saw? I mean, some specifics would be really helpful here on what was in particular in violation. Is it something that you saw go past a certain temperature range? Is it a misfiring? Because it sounds like there's a lot of software-related issue more than perhaps a hardware-related issue. And I'm wondering if you could get a little more specific on what the actual violation that was causing that failure was. Even if you're not necessarily sure of what the source is yet, it'd be nice to know some specifics around exactly what was causing that need to be recycled. And attached to that question is, then when you recycle them and you do those hot fires, what exactly is it doing to clear up the issue? And maybe you can specify a bit more on how that hot firing solves the problem.
Let me start, and I think Steve can get a heck of a lot more detailed than I can. But I want to not correct, but just explain a little bit. The hardware, the thrusters worked great, and by refiring them, we proved that. So it's the conditions that we've put in the software that is somehow telling the thruster to be deselected. It doesn't fail, it is being deselected. And that's not a software problem. That's the data we're putting into the software that needs to be understood a little bit more so that we can not deselect those thrusters and keep them operating. Steve?
Yeah, I think Mark said it really well. What we're really looking at is the way you determine a thruster is healthy on the spacecraft is you really have some temperature measurements that you can tell if there's any leakage of the propellants. We don't see any of that. When you fire the thruster, you know that there's a chamber pressure measurement. It measures the pressure in the chamber, and you're looking for a certain pressure in that chamber. And what we see sometimes on some pulses, that pressure doesn't get quite to the limit that it needs to. And if you get 5 consecutive strikes where you're not at that right pressure, the software says, hey, that's not a good thruster. Even if let's say, I think one of the thrusters today, it needs to get to 110 pounds per square inch, and it was like at 108. So clearly that thruster is a good thruster, but just not quite there for some reason. So the software deselects it. We come back and we re-hot fire that thruster and maybe give it a little bit of time to cool off in between the pulses. And when we hot fire that thruster, we basically send a pulse to that thruster. We look at the chamber pressure in the thruster. And then we also look at how much thrust comes out of that thruster by how much it changed the vehicle, attitude and rates and orientation. And when we do that, we figure the thruster is healthy now. We can, once we look at the data and review it, we can tell the software, essentially, you can fire that thruster again, if that makes sense.
Thank you. Next, we move on to Tariq Malik from Space.com.
Yes, hello. Thank you very much. And I think I have a question for either Steve or Emily. I'm very curious about what the pace of the dock testing is going to be for Starliner by Suni and Butch while they're there. I mean, it's been a pretty frenetic pace to get to the station. We've got a weekend coming up. Do they get break time? How much are you looking forward to? And then, Emily, for the station itself, what types of things are you looking at to see how it performs docked at the station to make sure that everything is good to have so many different visiting vehicles connected at that same time? Thank you.
Yeah, thanks for the question. The good news is they do get at least one day off. The bad news is because they're only scheduled to be there for a relatively short time, we work them a lot harder than we work our ISS crews. And so we are actually allowed to work them more hours of the day because they're only going to be there for a little while. A lot of the work that they're going to be doing is getting us ahead operationally for the Starliner 1 mission. And so there's emergency equipment that we want to have installed in visiting vehicles. And we had a little bit of a challenge with a shelf that we need to install that on the last mission, so we're going to make sure that that hardware can get installed properly. We're going to have them check out grab some of their ISS crewmates, go inside and see how would 4 people configure themselves to sleep in the Starliner, because being in microgravity is a way better test of how would you want to organize yourselves for those kinds of things. We're going to, there's a lot of checkouts there's Wi-Fi checkouts, and we have the tablets that the crew uses for their timelines and for all of their procedures. We're going to do a lot of kind of housekeeping activities with those things. We're going to be working on, we're scheduled to do a sublimator refill. We actually already knocked that out. We may manage to do another one just to top off the sublimator before we come home. We're going to do suit and seat checkouts, just a whole lot of habitability assessments to make sure that the crews coming up on the upcoming missions have a good starting point. Was that your only question, or did I miss one? Okay,
that was it. All right, up next we have Bill Harwood from CBS News.
Yeah, thanks very much. I'd like to follow up Jeff Faust's question from before. Given that you had these 4 helium leaks in different manifolds or similar systems, if this turns out to be a generic problem, you all told us before launch that, to go into the one you knew about is fairly invasive, given the hazardous materials you've been exposed to. Are you going to have to do that, given you've got multiple leaks in this system? Are you going to have to go tear this down when you get it back? Well, you don't get the service module back, but are you going to have to do some of that on the vehicles you have in flow? And how might that affect certification? I mean, it seems like that would really throw a wrench into the plan to get these guys ready to fly. Thanks.
Yeah, we've already started doing some of this work. We have multiple dog houses not installed on the vehicle that we are starting to tear down, and we're looking at how to do some type of screening test where we can determine if these seals are leaking on the ground with some level of pressure to them, so that we can screen for this problem. We also have the service module 6, which is ready, or getting ready for Starliners, or for Starliner 1, and that system is not filled with propellant yet. So we can break into that if we need to and do some work. So, we need to go lay this out and see where it ends up, but it's too early to tell. We got to determine what we think the problem is and what the actions are required to go do it. Right now, the vehicle flow, the hardware assembly is well ahead of schedule. So if we had to go plug something in, if it wasn't too invasive, we could probably fit it in.
Yeah, and I agree with everything Mark said. I think we've got to go figure out, is it the flange only, is that the only leak source, or is there some other leak source? How do we check it out on the ground and get ready to fly Starliner 1? And then as Mark builds his plan, we'll work together with Mark and we'll figure out what it means for certification.
Up next is Brendan Byrne with NPR.
Hey, thanks for taking my question here. Again, about the helium, I think you mentioned at the start that with everything closed, there's still a small leak, like something like 7 psi per minute. Is there a concern that could intensify even with the rest of the manifolds closed, and how would that impact operations on the station? Thanks.
Yeah, I'll take that one, and maybe I didn't make it clear. Right now, we are using no helium. There's no helium leaks. So with the manifolds closed, we know, and we looked yesterday, that there's no leakage in the tank. All the leakages in the downstream plumbing in the doghouses, so we're not leaking any helium right now. So that's the benefit of the space station and docking to the space station. We can sit in this configuration for a number of days, understand the system, understand if this is thermally driven. Is there something that we did as we were firing the thrusters on the way that maybe heated the system up? So we just get to take our time and understand where we're at before we undock and land. But right now, we're not leaking any helium at all.
Thanks, Steve. Up next, we have Mark Harrow with Aviation Week Space Technology.
Yes, thanks. I believe this is for Jim Free or Steve Stich. is there anything in the challenges you've seen so far that would require another crew flight test before you could certify Starliner?
Yeah, I'll start, and Jim can add. I don't see anything so far that would add another crewed flight test to this point in the mission through docking. If you look back, the sublimator issue, we've dealt with problems with water in space. The space shuttle had a flash evaporator system, which is a similar technology where you run a coolant loop through an area where you spray water on it. That water flashes into space and takes the heat away. That would freeze up at times. Our spacesuit that we use today uses a similar technology, so I don't really see that as a problem. The helium leaks, we just have to go take our time to work through it and figure out how we can make the system leak tight on the ground. If you look back toward OFT2, that system was much tighter for some reason, and we had a couple of really tiny leaks when we docked. And then thrusters, it's an issue that we faced on OFT2, and now we just have to work through, maybe including some extra hot fire testing on the ground of a thruster to see what's causing it. And I'll see if Jim has anything to add.
I'll just say it's almost 31 hours to the minute since launch. So, I mean, and you've seen everything that's happened in that 31 hours, and these folks on the panel and the teams that are out there have not slept. So I think, let us process the data. These folks put 2 people on space station in 31 hours and tested the heck out of the vehicle. So I think right now the time is to focus on that and figure out how we're going to get them the testing done on station and then get them home.
Thank you. Next up, we have Chris Davenport with the Washington Post.
Good afternoon. Thank you. I'm just wondering, while you have the spacecraft attached to the station, is there anything you can do in terms of maybe sending the astronauts out there to inspect it and see if they can find out what's going on with the thrusters, or if the ground controllers to do it? Steve, you had said, you want to take some time to assess it. I just wonder if that's going to happen sort of after the mission is over, when you've lost the service module, or if there's anything you can do in the next week or so. Thanks.
Yeah, I think with the helium leaks, those are inside the doghouse with the covers on, so I don't necessarily see that the crew wouldn't have any way to really go out and do any kind of investigated leak checking inside the doghouse. That's best done, as Mark described, on the ground in the processing facility with the next vehicle. We can do lots of different tests there on the ground, even some thermal tests on the ground. And then thrusters, we're going to go take a look. We requested some imagery of that back area. Again, I think the thrusters are working fine, and maybe we didn't describe it very well. The thrusters, when they're active, are firing and producing the right amount of thrust. These our reaction control system thrusters produce about 100 pounds of thrust each, so we're getting that thrust out. It's just sometimes the software is deselecting them, so don't necessarily see that flying around or doing anything else other than being docked to station is the right course of action at this time.
All right, up next we have Anthony Leon with Spectrum News.
Hello, thank you so much for taking our questions. This is for Emily Nelson. Earlier, you said something about there were some safety or emergency measures that were not included in Starliner, and I'm just wondering what they were. And as a quick follow-up, going forward, would NASA and Boeing consider some more uncrewed flights to make sure they work everything out before they put people back on board? Thank you very much.
Certainly. So for the emergency hardware I was referring to, we have some emergency scenarios on the space station itself that the crewed vehicles are the safe haven, the escape pod that you then have the astronauts escape to. And in some situations, you have them stay in there for up to 24 hours while you sort out what's going on ISS. For those cases in particular, rather than flying hardware up and back down again with each mission, we have the hardware the hardware that they need to remain safe for those 24 hours. We just have that hardware on the space station, and once a spacecraft docks, we then put that hardware in that fresh spacecraft, and then before they undock, we take it back out again so that we're not flying the same hardware up and down over and over again, because as of today, we've never used it yet. And so that's what I was talking about when it comes to the emergency supplies.
It's basically a deep contingency where the station becomes atmosphere is uninhabitable. The crew's getting in. Starliner, we do the same thing with Dragon, by the way. We use the same equipment in Dragon, and we actually have it installed in the Crew 8 Dragon if we were to have a problem on station. So we're doing that same test of that same equipment with Starliner. It's a contingency. We just want to get it installed and check it all out for Starliner.
Make sure it fits.
All right, our next question comes from Andrea Leinfelder with the Houston Chronicle.
Hi, I just want to confirm that you are now up to 4 helium leaks, correct? 1 before launch, 2 found in space, and 1 at the space station after being docked. And then just double check that that's helium used to pressurize the thrusters for fuel lines. Thank you.
Yeah, you're exactly right. We had 1 leak before launch. That was in what we call our port doghouse manifold 2. And that leak rate got a little less from where we had checked it in the vertical integration facility out to the pad. And then since then, yesterday we found 1 in port manifold 1 and 1 in top manifold 1. And then today it was starboard manifold 2. So, and that's what we're managing, and that's what we're doing the analysis that Mark talked about to look at our margins relative to the rest of the mission.
Next on the phone, we have David Curley with Full Throttle.
Thanks very much for doing this. Mark Nappi, great smile yesterday. 2 questions. On Harwood's question about what do you do with the next capsule? You a flange or a seal or something is problematic there. Do you kind of stop or to figure out what's going on before you progress with that? And secondarily, you had this question in the last couple of days about video and live video. It was a little bizarre to hear Suni saying, and here is Butch showing something to the other camera. Have you and Boeing management decided that maybe on Starliner 1 it's time to do live video?
So on the second question, we do have we did start putting the downlink hardware into the capsule. We didn't finish it for this flight, and that's something that will work for the future. We do record the data, and the crew can turn off and on the cameras, but we can get that data once we get on the station, and we'll download that. And in the future, we'll likely have some downlink capability. The first part of your question, no, we're not just going to stop. Like I said, we have to develop some kind of screening technique for this, and that is already in work, and the teams are just getting ready to tear some of that hardware down this week so that we can start that test criteria and see if we can come up with something that will look for these problems. We will also work with the supplier and determine if we were to take that flange assembly apart or look for other areas in that doghouse that could be potential leak sources, where would we look and how would we do that? So there's plenty of work to do before we come to some kind of conclusion that we know where this is at and what we're going to do about it.
Thanks, Mark. And the next question comes from Sophie Sanchez with Cosmic Chicago.
Thank you. This question, I believe, is for Steve. You mentioned that the issues that you saw today require the need for more manual piloting. Do any of those issues point to the need for additional manual flying during undocking or any of the return operations, or will they lead to changes in any of the undocking procedures? Thank you.
Yeah, we haven't totally spent a lot of time looking at undocking. I don't foresee, since we just docked a few hours ago. So I don't think that we would need to do any manual flying during undocking based on what we saw today. Again, the manual flying today was a little bit about as the thrusters failed, and we were in the process of recovering them, there was some iterations between the ground and the crew, and the vehicle being in what we call free drift, so no thrusters can fire at all. And then we drifted, while we were doing those checkouts, we were in a safe configuration. We were on the very front part of station flying, 270 meters from station. And so we needed to move back in a little bit, and we had the crew doing some of that flying.
Yeah.
And that part went really well. Undocking is a lot simpler. We just move away from the station and do some simple burns. So.
I'd also note that most of the procedures we executed today, we actually also executed in similar situations on OFT2 when we didn't have a crew. And so having the crew do the manual piloting is partially for the crew's benefit so that they get the experience and they can tell future crews what that looks like, how it's different from the simulators on the ground. It's also just simpler because they're there, but the ground team would have been able to send most of those commands as well if this had been an uncrewed flight, because we did have experience with a lot of these operations. And so in an undocked scenario, if we had additional thruster failures and we needed to get those thrusters back, we'd execute those same procedures again. But that doesn't change the undock itself. That just helps us do additional hot fires of additional thrusters if we need to, which we also did on OFT2, as Steve mentioned before.
Thank you. We are now moving on to Lauren Grush with Bloomberg.
Hi, thank you for taking my question. My question's for Steve or Mark. I'm wondering if we can get some context about how the variety of issues Starliner experienced today compares to other vehicles like Crew Dragon, Space Shuttle, or even the Soyuz. To the average person, or at least to me, it sounds as if Starliner has a lot of glitches and technical problems that keep popping up. And I'm wondering if we can quantify how these compare to the various glitches and issues that have popped up during flights of other vehicles, which at least outwardly don't seem as abundant. So is that a fair judgment, or do we consider this normal spaceflight behavior within the context of other crewed vehicles? Thanks.
Yeah, maybe I can start and maybe Mark can add. I would say some of the challenges that we are facing for this flight are very similar to the Space Shuttle when I talked about the cooling issues with having water in space relative to the shuttle had the flash evaporator system that was used for cooling during the transition to ascent before we got the payload bay doors open, and then after we closed the payload bay doors before entry. We used that system to provide cooling. We had numerous freeze-ups with that system, numerous problems. So I would say that this phenomenon of using water in space to cool is something that's always a challenge. So that's not necessarily something for Starliner. That's just a challenge that we always see with that system. And then I would say that the rest of the learning that we have relative to the helium leaks and the thrusters are very similar to the learning that we've seen on other vehicles, whether it be Space Shuttle or even some of the early Cargo Dragon flights. If I look at where, the Crew Dragon is, people forget that SpaceX leveraged heavily their Cargo Dragon to get to the capability they had with Crew in terms of their flight software, their thrusters, and other systems on the vehicle. So it was kind of an evolution to get to the crewed vehicle, adding the life support systems and the abort systems and then the parachute system. So, I would say there was learning there in the cargo vehicles that helped SpaceX get to where they are on the crew vehicles. If I step back and look at shuttle, I think we had learning on every single flight relative to things that we learned on every single system. Some we redesigned. The first shuttle flight lost tiles in orbit as the vehicle returned. It had a major overpress of the OMS pods at liftoff that we didn't understand. The vehicle for STS-1, when they landed the vehicle, when Captain Young landed the vehicle, the ground effect was different than was expected, and so he had a heck of a time landing that vehicle. So that was a traditional kind of issue that you see with a new development. And, if you really step back, see the crewed flight test is a little bit like STS-1 from a new vehicle perspective, first time with crew.
Yeah, I definitely would. If you're going to make a comparison, you make a comparison from this flight to STS-1. I joined shuttle in about the 1985 time frame when there were 20 or so flights, 25 flights behind us already, and we were still learning a great deal, way more than what we're learning on this vehicle. We have two problems on this vehicle right now: the helium leak and figuring out how to fine-tune these thrusters so that they're not selected off. Those are pretty small, really, issues to go deal with, and we'll figure them out for the next mission. So I don't see these as significant at all.
Thank you both. We now have a question from Ken Kramer with Space Up Close.
Hello, thank you. Thank you for doing this. My question is, I'm not sure who this is for, maybe Steve, maybe somewhere else. Will you be returning that defective UPA, and are you going to bring any science samples or other hardware back on the mission? Thank you.
I think that one's for Jeff, actually. So.
Yeah, so we don't plan on bringing back any of the pump that we would put in the UPA. Like I said, we want to try and put the new one in tomorrow, and hopefully it spins up and everything works well. It turns out the one that's on orbit today with another one that's on orbit, we're actually looking at some, we call it in-flight maintenance. We're cannibalizing one of the pumps to try to maybe take the motor out and create a new pump, since it's such a vital part of what we need to process water and, well, urine and then water. So no, we don't plan to bring one home. In fact, on our next Northrop Grumman flight, we're bringing up another pump module. So we're going to have a pump module party, I guess, and then maybe we'll start cannibalizing if we need to do that.
All right, thank you. And we have a follow-up from Joy Roulette from Reuters.
Hi, thank you for taking my follow-up question. I was just wondering, I know Boeing and NASA are in the midst of a battery redesign study connected to Starliner's batteries. I was wondering if the teams are going to take a look at that while Starliner is on the space station at all, or run any tests related to the batteries. And also, how long can Starliner on this mission stay docked to the International Space Station? Thank you.
I can start and see if Mark has anything to add. Yes, we do have a battery upgrade that we're studying right now. Obviously, we're collecting data from this flight relative to that battery upgrade. So far, the batteries have been performing well. And if I remember right, the dock duration can go up to 45 days.
Okay. Next question comes from Tim Bernholtz with Payload Space.
Hi there. A quick follow-up. I believe someone mentioned that there was a request for imagery of the rear portion of the Starliner. Who did you request that imagery from?
So, yeah, it's pretty standard that we'll use the various assets on the International Space Station, our truss-mounted cameras and the cameras on the robotic arm, to survey our visiting vehicles, make sure that they're in good shape before we let them depart. So we'll do that for the Starliner tomorrow, actually. We do that from the ground. Our robotics controllers here and in Montreal execute those procedures. We do that for the Dragon before they leave. We do that for Soyuz before they leave. It's a pretty standard procedure for us. And in this case, of course, if there's any piece of hardware that we're specifically interested in, then we target those and have our imagery folks take a look at the results.
Thank you. And the last question we have time for today is with David Curley from Full Throttle.
Thanks very much. Jim Free, you've been sitting there for a while. So talk about the big picture. I mean, we're 3 administrations back when commercial cargo, commercial crew was thought about, and this is a significant effort to accomplish what was thought of back then. What does it mean to you? What does it mean to NASA? Here's your big picture. It's the big softball. Have it.
Well, I appreciate the softball, but I would love to answer some of the prop questions.
I can take this one. You can go.
I mean, I think some of it I captured in my opening remarks. This is, NASA set out to create an opportunity for commercial space, first with cargo, then with crew, return and crew launches from the U.S. I think this is another step down that path. It shows what NASA can do by leading people to a commercial space industry. We're starting that now with a commercial LEO destination. We're doing a lot more with services to bring commercial space with us. Boeing's third launch of Starliner, first launch with crew, is another step in that direction. What we're doing, what you see on Space Station happening today with the National Lab, what we're doing commercially there to allow science and innovation and entrepreneurship with companies happening every day on station, getting our crews there, getting our cargo there, getting cargo home. I think we've set that path, and you're just seeing us execute it. And the time that you talked about 3 administrations ago, ultimately it's about doing this in a way we do it safely and do it successfully. And that's going to take time, and it's going to be different time increments for different architectures, different approaches, and you're seeing the Boeing architecture and approach come to fruition with Butch and Suni climbing through that hatch today.
Thank you, Jim, and thank you to all of you for being here today to answer questions, and everyone who has dialed in not just for this briefing, but followed the mission over the last couple of days. Before we close, our coverage of Starliner astronauts' visit will continue over the next several days with a number of in-flight events that begin on Saturday, June 8th at 1 p.m. Central Time, 2 p.m. Eastern Time, with Butch Wilmore and Suni Williams providing a televised tour of Starliner. For all of our programming throughout Starliner's mission, please go to the NASA television website at www.nasa.gov/NTV. And with that, we leave you with a little recap of what has occurred over the last couple of days. Thank you for joining.
Houston, Starliner roll. Roger roll.